Lesson 6, how can I describe functions? So we're going to do this exploration starting with A. We have the function y equals 2x squared minus 3. So we're going to create this function table or complete the function table. I'm going to use -2, -1, 0, 1, and 2 as my inputs. So we're going to substitute each of these into this function to figure out what our output is. So 2, instead of x, I'm going to put -2. Okay, so we need to take care of our exponent first. -2 times -2 is 4. 2 times 4 is 8. And 8 minus 3 is 5. So 5 is the output when the input is -2. Okay, now we'll do the next one. Substitute -1. -1 times -1 is 1. Oop, that should be a negative. So I get 2 minus 3, which is -1. Next, 2 times 0 squared minus 3. So 2, we get 0. And 0 minus 3 is -3. Okay, substituting 1. So 1 squared is 1. And 2 minus 3 is -1. Substitute 2. 2 squared is 4. And 8 minus 3 is 5. All right, now we're going to graph these ordered pairs. So I'm going to graph -2, 5. Start at my origin, go over to -2 and up to 5. -1, 1. Over to -1, down to -1. 0, -3. 1, -1. And 2, 5. All right, now I'm going to graph this. Okay, this is a function. If I were to use the vertical line test, it would only cross at one point. Let's go to B. So this is the same equation we just did, except there's no exponent with x. So we're going to do the same values, -2, -1, 0, 1, and 2, and substitute 2 times -2 minus 3. So that's a -4 minus 3, which is -7. Now we're going to substitute -1. Gives me -2. -2 minus 3 is -5. Substitute 0. 2 times 0 is 0. And 0 minus 3 is -3. Substitute 1. 2 minus 3 is -1. And substitute 2. 4 minus 3 is 1. Okay, ready to graph. -2, -7. -2, -7. -1, -5. 0, -3. 1, -1. And 2, 1. Okay, graph my line. All right, let's compare A and B. So first of all, we're going to look at the equations. So equation A had an exponent Equation B did not. All right, compare the tables. Say table A. Let's look at if they're constant or not. So to go from 2 to -1, we add 1. To go from -1 to 0, we add 1. Here we add 1, and here we add 1. Okay, so that's a constant rate. Let's look down here. To go from 5 to -1, you subtract 6. And to go from -1 to -3, we subtract 2. So right there, I can tell you this is not constant. Otherwise, these would be the same. You would remove or add the same amount each time like you did up here. So this shows that this table is not constant. Now let's check out table B. All right, so to go from here to here would be add 1. This is adding 1, this is adding 1, and this is adding 1. Now let's check out the bottom. To go from -7 to -5, you add 2. To go from here to here, you would add 2, and add 2. So this is showing a constant rate of change. All right, now let's compare the graphs. So graph A was curved. It is a curved line. It is not straight. Graph B is a straight line. So graph A, curved or not straight. Graph B is straight. All right, so comparing equation A, equation B, table A, table B, and graph A, graph B, we can determine that when an equation contains an exponent, then its rate of change will not be constant and its graph will be curved. Its rate of change will not be constant and its graph will be curved. Okay, let's go on to the next one. So describing rate of change. All right, we have these different representations, and we're going to write down what it is that we need to check. So when you're looking at a table, just like we did in the exploration, you're going to check its rate of change. If it's constant, then it's going to be linear. If it's not constant, then it's going to be nonlinear. When we looked at our two equations, we looked at the variable. If there was no exponent, we ended up with a linear graph, a linear function. If there was an exponent, then it was nonlinear. Okay, our graph, we're going to look at the line. If it's a straight line, it's linear. And if it's curved or not straight, then it's nonlinear. So linear functions, you will have a constant rate of change in a table. There will be no exponent in the equation, and the graph will be a straight line. If it is nonlinear, the table will not show a constant rate of change. There'll be an exponent in the equation, or the graph line will be curved, not straight. Okay, there's other ways that you can describe slope, and that's using SlopeMan. So we're going to fill this in. Underneath this little eyebrow, we're going to put a plus sign, because if the line is going in this direction, it is called a positive slope. If the graph of the line is going in this direction, then it's a negative slope. If the line is up and down, then we're going to put this little U for his nose, because that means it is undefined. Undefined. And if it's going straight across, put little dimples, then that is a zero slope. All right, here are other ways to describe rate of change or slope. So we can use the words, it's a positive, which we got from SlopeMan, or negative. We can say undefined, or zero. We can say slope is increasing, or we can say it is decreasing. So those are some of the ways that you can also describe slope or rate of change. All right, let's take a look at these different descriptions and decide how we can describe them. So I'm going to look at the rate of change for this table. So when I go from here to here, it is plus 10. From here to here, plus 10, and here to here, plus 10. Okay, so that's constant. Now let's look here. From here to here is plus 30. And from here to here, that is minus 20. And from here to here, it's plus 10. So there is definitely not a constant rate of change. So that means that this table was nonlinear. Justification, not constant. All right, let's look at the equation. First of all, I want to get it into slope-intercept form. So I need to do some rearranging. Let's add 6x to both sides. Divide by 3. All right, so now that I have it in the right format, I can see, okay, I have a constant, I don't have any kind of an exponent on x. So that means that it would be linear. There is no exponent. All right, looking at the graph. I'm looking at this line and it is perfectly straight. So that means that it would be linear. It is a straight line. Linear line. All right, next table. Look at our rate of change. So this is +2, this is +2, this is +2. So far, so good. Okay, let's look down here. This is +2, this is +4, and that is +1. So that means it's going to be nonlinear. It's not constant. Okay, now we're on the equation. Okay, so it is in y equals mx plus b format, but I see an exponent. So that means it's going to be nonlinear. There is an exponent. Okay, looking at this line, and it is definitely not straight. It is curved. So it's going to be non-linear. Okay, last three. Let's take a look at this rate of change. So from -4 to -1 is a +3. This is also +3. And this is +3. Okay, let's look down here. This is +5, +5, +5. So we do have a constant rate of change. So this is linear. Okay. In an equation, I have to look at my variables, see if it has an exponent. There's no exponent, so it will be linear. And then looking at this line is straight, so it is a linear function. And those are examples of how we can describe slope or rate of change.